All right, so we're just going to start with classifying triangles. These are things that you probably already know, but I'm just going to go over it actually fairly quickly. So first thing is classifying your triangles. So the first one is classifying by angles. So there's two ways to classify your triangle, by angles and by sides, and you do need to know that distinction. So first thing, classifying by the angles. This first one is, of course, an acute triangle, and it's a triangle that has all acute angles. So I'm going to be using my abbreviations. Next thing is an obtuse triangle. That's a triangle that has an obtuse angle. Okay. And so we talk about that because an obtuse triangle is going to have one obtuse angle, the other two angles are going to be acute. And I want you to think about why a triangle couldn't have two obtuse angles. My next one is a right triangle, and it's a triangle, there we go, a triangle with a right angle. This next one, this is probably one of the newer ones. This is an equiangular triangle, and it's actually in the name equa, meaning equal, angular meaning angles. So an equiangular triangle is a triangle with all equal angles. Okay, all congruent angles. Things that you need to know, that you should know before you got to this class, is the sum of the interior angles of any triangle is 180 degrees. So if all of these are equal, this one, and they add to be 180, well, 180 divided by 3 is going to be 60. So the measure of each angle in an equiangular triangle is going to be 60 degrees. All right, next thing, just kind of going through this quickly, is of course your scalene triangle. Scalene triangle has no congruent sides. Okay, so that's the first one. None of the sides are the same measure. Next one is isosceles, and that is at least two congruent sides. And we're going to talk about what that means because it's at least two congruent sides. When we talk about equilateral, parts of your isosceles triangle, and actually I didn't go back up, I'm going to go back up really quickly, just so you know your parts of your right triangle. So my right triangle has two, these are called the legs, and this of course is the hypotenuse. Okay, so those are the parts of your right triangle. An isosceles triangle also has the parts, each part has a name. The two congruent sides are called legs. Okay, so leg is going to be the congruent sides, and the base is normally the non-congruent side. Okay, so here is the base. Oh, sorry about that. Okay. This right here, this one right here, this is called a vertex. And these, it's called the vertex, is a vertex angle actually. And these two right here, these are called base angles. So this one and then that one there are called base angles. Okay, I should have left a little bit more space in hindsight. That would have been a good idea. Last one, of course, is our equilateral triangle. Okay. My equilateral triangle, again, it's in the name. Equa meaning equal, lateral meaning to the side. So when you talk about a lateral move, you're talking about to the side. Equilateral triangle means it has all sides congruent. Now, what I mean is when it says at least, so a definition of an isosceles triangle is it has at least two congruent sides, which also means that an equilateral triangle is a type of isosceles triangle. It's an isosceles triangle with three congruent sides. So that's what I meant there. Okay, picture drawing. That's really important in this class, at least to get that visual of what we're dealing with. So for our first example here, It says find x in the measure of each side of equilateral triangle RST, blah, blah, blah. So it says I have an equilateral triangle, so that's what I'm going to draw. Doesn't have to be perfect. And I know it's triangle RST, so each of the vertices are RST. It says the distance from R to S is x plus 9. It says the distance from S to T is 2x, and the distance from R to T is 3x minus 9. And the big thing that I know is that all of the sides are congruent. So it says solve for x and find the measure of each side. So I have a lot of options to solve for x. I can say, well, x plus 9 side is equal to the 2x side. Or I could say the x plus 9 side is equal to the 3x minus 9 side. Or I could say that the 2x side is equal to 3x minus 9 side. You don't have to do this 3 times. I'm just going to go through it really quickly just in case you picked a different one than I did. So I'm going to subtract x from each side. This then ends up being 9 is equal to x. So that was easy enough. If I did this right, then the rest of them are going to be the same. Subtract x, subtract x, subtract x. Just erase that because I don't want to confuse you guys. Subtract x, so I have 9 is equal to 3x minus 9 plus 9 plus 9, 3x is equal to 18, divide by 3, divide by 3, x is equal to 9. So see, I got the same thing there. And if you did this one, this is going to be negative 1x is equal to negative 9, divide by negative 1, x is equal to 9. So so 9 is definitely my answer. So I know x is equal to 9. The other thing is find the measure of each side, so I plug that in to the original problem. So this is going to be 9 plus 9, which is 18. If I did it right, then each of these is going to be the same. This is going to be 27, or this is going to be 27 minus 9, which is also 18, and then 2 times 9, which is also 18. So we did it right. So each side is going to be 18, and x is 9. So those are your 2 answers. Again, you don't have to do it 3 times. I'm just explaining to you that it didn't matter what side you pick because it was equilateral. Okay, the next one. I know this has a V in it. It should be triangle. I'll fix that. So triangle JKL. So the first thing I do is I draw triangle JKL. Okay, and it says KJ, so KJ is congruent to LJ, so those are my congruent sides. All right, it says JL is 5 less than, so minus 5 less than 2 times a number. JK is 3 more than, so I always write the plus 3 more than the number. Okay, and KL is 1 less than, so I'm going to put the minus 1 over here, than the number. Okay, and it says find the measure of each side. So I go to, so I actually draw that in my diagram. So JL is 2x minus 5, JK is x plus 3, and KL is x minus 1. And this is a K. I know that this looks really funky. Okay. So then I use what I know. It says it's an isosceles triangle, and these 2 sides are congruent. So those are the parts I'm going to set equal to each other. So this is 2x minus 5 is equal to x plus 3. Sorry, didn't mean to do that. All right. So subtract 2x, x minus 5 is equal to 3. X is equal to 8. Okay. Once I have x is equal to 8, it says find the measure of each side. So I substitute 8 in. So this is going to be 8 plus 3, which is 11. This is going to be 2 times 8 minus 5, which is 16 minus 5, which is 11, which tells me that I know I did this right because those sides should be the same. And my last side is 8 minus 1, which is 7. So you'd write JK is equal to 11, JL is equal to 11, and KL is equal to 7. All right. Next thing it says, find the measures of the sides of triangle ABC, and then classify the triangle by its sides. Okay, so we have to do distance formula. Okay, and I'll just draw a triangle right here, A, B, C. So first we define the distance from A to B. That's going to be the square root of, I subtract my x's, -4 minus 5 squared, plus, subtract my y's, 1 minus 6 squared. Distance from A to B is equal to -4 minus 5, that's going to be -9 squared, plus 1 minus 6 is -7 squared. Distance from A to B is equal to 81 plus 49, which is going to be 100. So the distance from A to B is radical 130. And we'll talk about simplifying that, but actually for this, it's not asking for what the side says. Find the measure of each side. It's in simplest radical form, and it might be easier to kind of compare the sides from here. So classify the triangle by its side. So AB is 130. Now I do from B to C, let's say. So I do square root. That's going to be 5 minus -3 squared plus 6 minus -7 squared. Distance from B to C is equal to 8 squared plus 13 squared. Distance from B to C is equal to 64 plus 169. And so the distance from B to C is radical 233. So far, none of the sides are the same. Okay, and then I just do the distance from A to C. So the distance from A to C, that's going to be -4 minus -3 squared plus 1 minus -7 squared. Distance from A to C is going to be -4 minus -3 is going to be 1 squared plus 1 minus -7 is going to be 8 squared. Distance from A to C is equal to 1 plus 64. That's radical 65. And so all of the sides are different. So this is going to be a scalene triangle. Okay. Identify all of the obtuse triangles if MJK, so MJK, this angle here, is congruent to KLM, and MJK is 126, and JNM, so JNM is 52 degrees. So I know that these are congruent, so I know this triangle here is obtuse, so triangle JMK. We also have triangle, then this guy right here is also an obtuse triangle, so triangle KLM, or whatever order. If this is 52 degrees, then the angle next to it right here is going to be 128. So this is also 128 because they're vertical. So JNK also, and the last one is going to be MNL. This one right here, because they have obtuse angles. And it doesn't appear that there are any others that are obtuse. So it's just those four. Okay, identify the right triangles if IJ, and this is perpendicular to GH, so IJ is perpendicular to GH, or parallel, sorry, I said perpendicular, parallel. So if those are parallel, that's given to you. GH is perpendicular to DF, so GH is perpendicular to DF. So those would have to be right angles if it's perpendicular. And GI is perpendicular to EF, so those would have to be right angles. Okay, if these two lines are parallel, then this angle here has to be right, which there's no triangle there, but this angle right here also has to be right, because these are, this angle here and this angle here are corresponding. So I'm just going to go through. We have triangle GDH. We have triangle GHJ. Okay, I have triangle GIE. So this one here. Okay, this one here, it's a right angle, but there's no triangle there. But I know that since this angle is congruent to this angle, IJF. And it'd be great if you could think of another one, but I think that's about it. So that's all you need to know for this lesson.